Okay, welcome to our new topic, that is data transfer. Data transfer, normally we use some register where data transfer from one register to another register. Our topic today, I will discuss regarding on data transfer. That means how data transfer from one register to another register. Okay, normally when we start our that is when we transfer our data from one register to another register, then how it will start, or how what are the process the data transfer from one register to another register. Okay, our topic is based on that data transfer. The question is, whenever it will transfer, what kind of a concept is required to define whenever data transfer from one register to another register. So here some question is considered, like how data transfer from one register to another register whenever a certain statement is true. That means some conditional statement is there, where statement is true, then that is a data transfer from one register to another register. Okay, this question I have to solve today. Now we see some question is given, then some statement I will write very simple way. I will write the statement, then we can find out how it is true, or how data transfer from one register to another register when that is statement is true. Okay, so let P is a statement. For example, let P is a statement, that is data transfer from, like a R1, data transfer from R1 to R2. That means when P is true, then data transfer from R1 to R2. Okay, R1 to R2. That means we can write in this way, like transfer data from R1 to R2 when P is equal to 1. That means P is equal to 1, normally we will consider whenever the condition or statement is true. Suppose P is a one statement, it is true, true is considered as a, that is 1. If it is 1, normally we will consider whenever statement is true, then we will consider as a 1 normally. If it is 0, you will consider as a false. If the statement is true, then what happens? Data transfer from, that is R1 to R2. This is the our statement. We have to design this statement through certain that is hardware part or certain logical part, how it is designed. Suppose this statement, that means this statement is designed through certain logical circuits or logical way, where data transfer from one register to another register. Okay, how we will design this data transfer? Okay, very simple way I will show you how it is designed. Okay, so now you see solution defined in this way. We can write the solution. Suppose this is the question, we can write solution in this way. But first of all, we see that is a two register we have to take it. Let that is one is R2, because R2 is given, that is R2. Okay, another register is R1. Okay, so here we can take, that is another register R1. Okay, that means data transfer from R1 to R2 in this way. Okay, you see, very simple way it is mentioned R1 to R2. That means direction, if direction is mentioned in this manner, that is R1 to R2, that means data transfer from R1 to R2. If more number of data, suppose transfer, then we can also write in this manner, here is n, in this way we can write n. That means n number of bits data transfer from R1 to R2. This is the basic concept. But when this data will transfer, it depend on the particular statement, that is P, is true. That means when P is true, then data will be transfer. Okay. That means we have to take some certain that is unit where the statement will be true, and at that time data transfer from R1 to R2. Okay. So now whenever we go through any conditional statement or some condition, then what happens, we will go through some control unit, because control unit always it control the different kind of a statement or different process. Okay, it is under this control statement. If it different statement need to execute, then it is under the control statement, because control statement know that which statement need to execute first or later, the defined by this control statement, or it is a decision by the control statement. In that case, you see how control unit defined this kind of that is a transfer, where data transfer from R1 to R2. So now we'll take one control statement here. Okay, very simple way I will write how control statement or control unit, actually it is control unit, this unit how it help to help to transfer data from R1 to R2. This control unit define the also use that statement. Suppose this particular direction we can take. So control unit find out which statement is there. Suppose P is a statement. If P is true, then at that time, then data transfer from R1 to R2. Okay. That means if P is true, if we can write also if P is true, then data transfer from R1 to R2 having n number of bits. Okay. This is the basic concept. We can take this is the basic concept whenever data transfer from R1 to R2. At what time or when it will transfer? At that time what happens? We just take one clock where it will help, that is data transfer from R1 to R2. Okay. This is basic concept we have to design with that is statement, where it's a conditional statement. That means if a conditional statement correct or a statement is true, then data transfer from R1 to R2. And at the certain time, for the reason one clock also design in this way, where data transfer from R1 to R2. Okay. Now we see, that means what happens here, very simple way, here control unit defined or find out if that is a statement is true. In that time also we can define this part, also we can define like a load. Okay. Load means R1, that is a data transfer from R1 to R2 in this. If the control unit find out the statement is true, in that case it will that is where data transfer from R1 to R2. Okay. Now you see how clock and load will consider whenever data transfer from R1 to R2. Okay. Now you see, very simple way I will design. One part is clock part, like we will see just clock part. Okay. So we can define all of you know that clock normally define like sometimes up and down, this kind of structure we can consider the clock. If down, then it will be 0. If up, that is 1. Normally consider, we most of the time we will consider. Okay. Suppose here is a t time. For example, here is a t time, and here is suppose t plus 1 time. Okay. In this t time and t plus 1 time, then what happens? Okay. That means if we consider this kind of a concept whenever go through clock, then data will store. Okay, data will not store, it will load from R1 to R2. How it is designed through load, I will show you how it is designed. Okay, now you see this kind of a concept also we can define whenever it will load from one register to another register. We can write this is a load. Okay, that means you see if we go through this one, that is a clock particular t time and t that is t time means t here t plus 1. This is actually t plus 1. This t time and t plus 1, at that time what happens, this time load will activate. Okay, and this time what happens, they will or data transfer, and whenever load reach at t plus 1, automatically data transfer from R1 to R2. Okay, this R1 to R2, whenever the t reach at t plus 1, just activate t time, but at t plus 1 it will what load data load from t plus 1 time. In this way, clock pulse also help how data transfer from register, that is register 1 to register 2, how it is working. Okay, this is the basic concept. Okay, so we can tell as that is this is the data transfer whenever we will consider that is data transfer from register 1 to register 2. This is a basic concept to design with the help of control unity, how control unity is considered, or how control unit is control the statement whenever data transfer from one register to another register, and as well as how clock and load will help to transfer data from one register to another register. This is the basic concept. Okay, through this basic concept we also consider application of this basic concept in another way. Okay, that means it is a one type of a transfer, that means one register to another register, like R1 to R2. At the same time, suppose data transfer from R2 to R1. Okay, it is also possible. Another statement also we can consider at a time. That is at a time means that is two time, not at time. The two time also we will consider data transfer from R1 to R2 and as well as R2 to R1 in a single statement. Okay, in a single statement also we can consider how data transfer from R1 to R2 as well as R2 to R1. So another way I will solve another problem. Now I will see you how another problem can be solved. Okay, so just a minute, I will show you another problems with the help of this basic concept. Okay, okay, so now another problem I have to explain. The problem is like this: draw block diagram of the hardware or with the help of hardware that implements the following register transfer statement. Okay, this is transfer statement, how it is defined or how it is follow whenever data transfer from one register to another register as well as reverse way. Okay, so here one statement is given like that is y t2. I mentioned here very simple way. It is like y t2. The statement is defined like R2 data transfer from R1 to R2 and R2 to R1. Okay, as well as R1 to R2 and R2 to R1 reverse way. How it is designed with the help of this hardware. Okay, now we see very simple way. We will consider here is only two register, that is R1 as well as R2. First of all, we see that two register first we have to take it. Okay, the register is considered like this. So very simple way we will consider the register. Two register we will consider One is R1, okay, one is R1, okay, another is R2, okay, two register just we consider, or we will draw two register very simple way, R1 and R2, okay, and here is two transfer, one is R1 to R2, another is the R2 to R1, two that is a transfer is there. Then you see, suppose the transfer from R1 to R2, okay, R1 to R2. So very simple way we can define R1 to R2, and here also n number of bits, okay, we define n is the n number of bits we can define. Also we can write here is n number of bits. N is number of bits. We can write number of bits, okay, n number of bits. N number of bits is defined by n. Then here again what happens, another statement is there, that is R1 to R2 to R1. Here is R1 to R2, that is data content transfer from R1 to R2. Here data transfer from R2 to R1. That means here R2 to R1 in this second that is expression. So here very simple way I will draw it like this. You see very simple way. Here some data is there. Here we just draw another data transfer from R2 to R1. Okay. So R2 to R1. Here very simple way. Same n number of bits also we can consider. Okay. Here also n number of bits, same n number of bits also we can consider. Any number of bits doesn't matter. Now we see here data transfer from R1 to R2. Here in this way data transfer from R2 to R1. But question is how it will transfer? Who will help to transfer the data from R1 to R2 or R2 to R1? But previous case I have already mentioned that previous case that simple statement is there. Statement is true. Then data transfer from that is R1 to R2 single way. But here the statement is defined another way. The statement is very simple way. It is mentioned that is YT2. You see very simple way it is mentioned YT2 means whenever we define the two variable YT2, like here one part is Y, okay, another part is T2. Two part is there. One is Y, another is T2. Here very simple way mentioned YT2 means Y, here is dot product also we can define like Y dot T2. Two parameter is there. Okay, YT2. Then what happens? One part is Y, another part is T2. If dot is there, then what happens? Which logic gates we will use to make YT2? Obviously, it is AND gate. AND gate we can take to make that is that Y dot T2. So we will consider one that is AND gate. Okay, very simple way. It is mentioned AND gate. Okay, very simple way we mention AND gate, and two data will take one part is that is Y, one part is Y, another part is T2. Okay, very simple way we can take. Then whenever this particular statement is defined YT2, already AND gate we can take it because it is Y dot Y2 T2. So one part is Y, another part is T2. Okay. Now this particular logic gate linked to the R1 as well as R2 because here is a two statement is defined. One is R1 data transfer from R1 to R2. Another is R2 to R1 in this way. So this will be defined through this particular AND gate. Okay, that means this particular AND gate load the data from R1 to R2 as well as R2 to R1. How? You see, very simple way. I will just draw this one, this part, another is this part. Okay. So here we can write that is a load. Okay, we can write a load, and here also we can write a load. Okay, that means this particular AND gate load the data with it will help to load the data from R1 to R2 and R2 to R1. Okay, whenever the particular expression is given. But the question is how it will work. Okay, how it will load at a time. It is possible to at a time load. That is we will see that how it will load. Last time also we defined whenever a load or a transfer of data from one register to another register, then what happens? Two part is required. One is load part, another is clock part. No problem. Whenever load is there, then what happens? With the help of that is AND gate, we load data from R2 to R1 or that is R1 to R2 or R2 to R1 in this way as our requirement as per the given statement. But now we just how or which part is that is load, first this one or this one. Now we see, we just take one clock where it will help to load either this one or this one. So very simple way I will draw this one. Okay, now very simple way I will show you how it is clock will help to load. Okay, now see, very simple way it is mentioned, that is one clock create a clock pulse. So first clock pulse suppose we define or we will take, then suppose this one first clock pulse start, then R1 data transfer from R1 to R2, n number of bits data transfer from R1 to R2. If we go through second clock pulse through this one, then data transfer from this R2, okay, R2 data transfer to R1, okay, data transfer from R2 register to R1 register. So in this way, so different clock pulse is considered whenever data transfer from R1 to R2 or R2 to R1. Okay, so this kind of that is a transfer of data can be considered in a single statement. Here very simple statement is mentioned with the help of AND gate. We know that this is a that is AND gate. We consider this is AND gate. This with the help of AND gate we design with the two inputs, one is Y and other is T2. We also consider different logic gates to design and to make that statement. Here is Y T2, other also variable we can consider as a inputs to the AND gate. Okay, we can consider, doesn't matter. So but how it will work, how data will store into the that is a register, either from one register to another register or data transfer from one register to another register, it will design in this manner. So it is very easy. We can also find out how, or we can also design how data transfer from one register to another register whenever data load through this logic gates and through this clock pulse. This clock pulse, suppose first clock pulse started, then data transfer from R1 to R2. Similarly, another clock pulse will start, data in that time data transfer from R2 to R1. In this way, the basic design we can create whenever data transfer from one register to another register with the different kind of statement. Okay, here is only that is a single simple statement YT2. We can consider like any other X, Y, Z, whatever the number of values or inputs we can consider to make one statement. Either we go through AND gate or OR gate also we can consider sometimes. Okay, so there is no problem. If the any kind of statement defined, we have to design the different that is a block diagram with the help of a hardware as per the given statement. That is a register transfer statement. Okay, so this is the basic concept I explained today. I hope all of you understand this basic concept and use this basic concept as you like. We can take different kind of statement as your choice. Also we can create the different block diagram with the help of hardware, how it will implement with a different kind of a register transfer statement. So I took one kind of example. We can take any kind of example and make different kind of a block diagram as per the hardware requirement. Okay, thank you very much. Thank you very much to watch my channel and see these videos. Thank you very much. Thank you to all. Thanks.